Alright, lesson 12, this is factoring the Gcf and Trinomials. So we're going to go into polynomial factoring. Okay, factoring means to break things apart. So just like we factored out a Gcf yesterday, or finding factors of 24. Remember doing this? This is called a factor tree. I'm breaking it apart to the prime factors of 24. Remember this example yesterday? Yes or no?
Yeah.
Okay, good. So, breaking apart a number, right? That's what factor means. But when we talk about polynomials, we're factoring a polynomial. And there are multiple ways to do that, but we need to focus on two today, which is factoring out the Gcf, or greatest common factor. You always check that first, and then you factor out using Xbox. Okay, Xbox is a method that I use. Raise your hand if you remember Xbox from before in one of my classes. Mrs. Bonomo and Mrs. Castro or other math teachers teach it differently. I teach it my way because I like it the most and I feel like it's easiest. Okay? But I don't care what way you'd use, you just need to get the right answer, okay? But for the sake of my class, I would suggest you learn it because that's all I'm going to use is my method. I'm not using anyone else's method. Alright? If you're online, these are the steps. Specifically, if you're making an Xbox again, the way you make an Xbox is draw an X, and then you draw a line through the X like this. You'll have to put A here, A times C here, and B here. Alright? So, if you're on the video, pause. If not, here we go. Numbers 1 and 2. Watch me work right now. Pencils down. So we got number 1, 5n squared minus 15n. It says factor completely, meaning I want to break it apart completely. So the first thing I always want to check for is the Gcf. So I'm noticing I'm looking at this term and this term here. The coefficients of each of these terms have a factor of 5. That's the greatest common factor, so I'm going to factor out a 5. If I look at these terms again, looking at each of the terms, I'm noticing there's an n there, so I can factor out an n. Then I ask myself, 5n times what is 5n squared? Well, 5n times n is 5n squared. Then I ask myself, 5n times what is negative 15n? Negative 3. Okay? Can't factor anything else, so that is the answer. Okay? I can't do an Xbox because there aren't 3 terms that I factored out after the 5n. Alright? Now, number 1, I could have also looked at it this way. If it's difficult for you to see the Gcf, you could factor out 5 times n for this first term right here. Right? Isn't that the same thing? And you could have also looked at the second term, and we notice this is negative 5 times 3 times n. And we're noticing on each list there's a 5, and there's an n that we could factor out. Okay? So that's an easier way to look at it, but once you get good at it, you'll notice that you could just go straight to the factor. Questions on number 1. 2. Okay, this one's a little more complex. Same steps. We need to check for a Gcf first. Okay, looking at each of my terms, I'm noticing that there is a 3 here. I'm also noticing that there's an x in each term, so I'm going to factor out the greatest, or the least, factoring out an x from each of these because there's an x to the first, x squared, x cubed, so x is the most I could take out. Then I ask myself, 3x times what is 3x cubed? X squared. 3x times what is negative 3x squared? Negative x. 3x times what is negative 6? Negative 2. Okay. Now I have the Gcf factored out, and I have a trinomial here. Since I have a trinomial here, I need to try to do an Xbox. In order to do an Xbox, you have to focus on what's your a, b, and c of the trinomial. The way you look at the a, b, and c is you look at the coefficients and the constant. So the coefficient here is 1, right? There is nothing here, so we assume it's a 1. There's nothing here, but there's a negative sign, so we assume it's a negative 1. So this is our b is negative 1. Our c is negative 2. You don't have to write a, b, and c out every time, but for the sake of the lesson, I'm showing you how to identify it. And we need to create an Xbox. So drawing an X with a line through the center, we're going to put a here and here. So I'm going to put 1 here, 1 here. A times C is negative 2. B is negative 1. I ask myself, what times what is equal to negative 2? It adds up to negative 1. So I know that positive 1 times negative 2 multiplies to negative 2. I also know that positive 2 times negative 1 multiplies to be negative 2. So I want to figure out which one adds up to negative 1. So over here we have 1 plus a negative 2 is equal to a negative 1. Okay, that's the 1. If I try to do 2 plus a negative 1, I only get 1, which is not the same thing as B here. So this is the wrong answer. Okay, so I'm going to use these two factors here, 1 and negative 2 here. It doesn't matter what order you use them. And we do a box. And I ask myself, can I simplify these two fractions at all? 1 over 1? Nope. Simplify 1 over negative 2? No. So now I'm going to take these two and I'm going to create two sets of binomials. Or two sets of binomials. And these are our coefficients. So we have positive 1, square root of x squared is x, so it's 1x plus 1. So I just copied this one here and this one here. Then we have positive 1x minus 2. And then I want to copy down the coefficient of 3x, or the original GCF. So it's going to be 3x times x plus 1 times x minus 2. Answer for number 2. Any questions on numbers 1 or 2? Okay, so what I'd like you to do right now is turn to your neighbor. Today's Tuesday, let's have 2's talk first. So 2's are telling the 1's about number 1 first. And then 1's tell the 2's about number 2. Ready, set, go. Number 3. So this one's like number 1, right? So turn to your neighbor, discuss a possible GCF, and factor it out. I know number 4 looks like number 3, so we're just going to skip number 4. But let's focus on number 3 right now. 5n squared, okay, so it's going to be 5n squared times what? N minus 9. Do you agree?
Yes.
Good, that's correct. Right? Because each of these has a factor of 5. That's your greatest common factor for the coefficient. In regards to n squared and n cubed, you always take the smaller exponent. So n to which power is smallest? N squared. Okay? As long as there are n's in each term. Number 5. Okay? I'll start you off here. What's the GCF you could take out of number 5? 2 what? 2x, right? So we got x squared plus 7x plus 12, right? I'll start you off on the x box here. The way you start your x box is draw an x, draw a line through the x, and then you have your a and a. So we have 1 and 1. A times c is 12. B is 7. Okay? Factors of 12 that add up to 7. This is what you ought to do. 1 times what is equal to 12? You start with 1 always. 1 times what? 12. 2 times what? 6. 3 times what? 4. And then 4 times what is already repeated because it's already here. Then we add them together. We have to add these and figure out which ones are my factors. Okay, so I'm going to 7, right? So this is the one we want to use because it's equal to 7. 2 plus 6 is 8. That doesn't work. 1 plus 12 is 13. That doesn't work for this example. Okay, when you get good at this, you do not have to make a list, but for today we will. Okay, now we box our fractions and we ask ourselves, are these fractions simplified? Yep, 1/4 and 1/3 are simplified. So now we're going to rewrite this as 2 parentheses. What's my first binomial going to be? What? X plus what? Good. Next one? Good. And? Good. Okay. Makes sense? Okay. Good. Yeah. No, it doesn't matter. What do you mean, like the x's or? No, it doesn't matter. That's a good question. Does it matter? No. The reason why is because of what property? The commutative property of multiplication. Okay, it doesn't matter. Good question. Okay, number 6 by yourself. This is it. Times, open parentheses. Oh. Okay, good. 2 times. Nope. Give me the final answer. Nope. M plus 1 times. Good. And then, of course, that's your final answer. So I'm boxing it. Okay, so that's it. That concludes the lesson.